During this math adventure, we have been working with linear equations. Our goal today is to work with something called systems of linear equations. Actually, it's not that difficult. All it simply means is we're going to have more than one linear equation on each coordinate plane. Now you can have 2, 3, 4, it doesn't matter how many you have. As long as you have more than one linear equation on a single coordinate plane, that's called a system of linear equations. Now, when we take a look at it, if we're going to have a system, it means we have to have two linear equations. And so notice it's in our format of y equals mx plus b. So if I have one line, which is y equals 2x minus 4, you know I can graph that by using the minus 4 as my y-intercept. And my slope tells me I'm going to go up 2 over 1, up 2 over 1. So you can see up 2 over 1, I put a dot. Up 2 over 1, I put a dot, and I can connect those lines. Now, I have to add the second line in order for it to be a system of linear equation. So here, I can see that my y-intercept is 1. I can see it's a downward sloping line, and it's going to go down 3 over 1. So I go down 3, 1, 2, 3 over 1. Down 1, 2, 3 over 1. As soon as I have 3 points, I can connect that. Now there's 3 kinds of solutions that we can have with the system of linear equation. We can have a solution that's a single solution. It means that the points cross at exactly one point. Or we can have a no solution. It means that the lines never cross. That means those lines have to be parallel. Or we can have an infinite number of solutions. It just means that one line is lying on top of the other line. Well, how do we know what our solution is? Well, when I went and graphed those two linear equations, I saw that they intersected right here at this point. And if I read what that point is, it's 1, negative 2. So I think my solution to both those equations is 1, negative 2. But I don't just take my word for it because maybe I didn't draw it correctly. So what I do is I go substitute that solution of 1, negative 2 into each of these equations. And as long as both sides of the equation are balanced, I know that that has to be the solution. So I'm going to take my first equation, which is y equals 2x minus 4. I'm going to substitute 1 in for x and negative 2 for y. And when I solve that, I get 2 minus 4, which is negative 2, equals negative 2. Yes, that is a solution to that equation. But I have to check the other one to make sure that one works as well. So I take that same ordered pair and I plug it in. I substitute 1 for x, substitute negative 2 for y, and I just see if it works. And when I solve that, I see that also is negative 2 equals negative 2. Because both equations came out to be balanced using the same ordered pair, I know that is a solution to those equations. And that's my goal. I want to find the solution. Now remember, sometimes there's not going to be a solution. Sometimes literally the lines are on top of each other. That means every XY pair that I would plug in would work. Often though, we only get a single solution, and that's the goal for that. Now, sometimes they're going to make it a little more difficult for you to actually find those equations. So sometimes they're going to ask you to write the system of equations. So they're going to give you something like this. Find two numbers with a sum of 6 and a difference of 4. And that's all they give you. Well, I have to create my x and my y, and I have to create that linear equation. So I just know I have to have x or y. I just decide x is going to be the bigger number, y is going to be the smaller number. There was no rhyme or reason to why I did it that way. I just thought of it that way. So always remember, though, you have to have those two variables. So then step 1 is I'm going to go write my equations. So I know that the two numbers have a sum of 6. So my first equation is I'm going to take my x and my y, add them together, and I know that has to equal 6. And then the second part of this is those two also have to have a difference of 4. So I know x is bigger, and you have to have a bigger number minus a smaller. So I know it has to be x minus y equals 4. Okay, I've got my equations, but notice they are not in proper function format. And so what I need to do is I need to correct that format. So remember, you take that original equation, you're going to subtract x from both sides, so you're just moving that x to the other side of the equal sign. So when I correct the format for both of those, I get y equals negative x plus 6 and y equals x minus 4. Now I can graph, because all I need to do is take a look at this plus 6, and I know that is my y-intercept. I know it's a downward sloping line, and it's going to go down 1 over 1. So I go down 1 over 1, place a dot. Down 1 over 1, place a dot. I create my line. So there's the line for the first equation. Now I go negative 4 as my y-intercept. I'm going to go up 1 over 1. So up 1 over 1, put a dot. Up 1 over 1, put a dot. Connect it. When I go to connect it, I'm looking for where they cross, because wherever they cross, I know that's my x and my y value. Well, where I see it, they cross right here. And if I take a look at that ordered pair, it's the ordered pair 5, 1. Now, I don't know if that's correct yet, so what I have to do, I got to go plug it in. And it just so happens when I plug these in, they are the correct solution. So if I go back, 5 is the greater number, 1 is the smaller. They are two numbers. When I add them together, they equal 6. When I subtract them, they equal 4. I know I've got the solution. Your job today is simply to be working with these systems of linear equations. You're going to take everything you've learned up to this point, and you're going to apply them to 2 or more lines on a single coordinate plane. I hope you have fun with this. I always enjoy this. Good luck.